Welcome to the OGV Innovations Podcast. My name is Bob Keeler. I'm the guest host of this podcast, and today I'll be speaking to two really interesting and very different companies. First of these is ARC Marine, based on the south coast of England, and they'll share with you what they're doing to have a huge potential environmental impact. Secondly, I'm going to be speaking to a team that originates from the west coast of Australia and what they're doing to apply machine learning and artificial intelligence to the world of asset operations and the huge benefits they can make. I hope you find this as interesting as I do. So now I'm going to talk to Tom Burbick from a company called ARC Marine, which takes us in a slightly different direction, but you'll find this really interesting. Tom, hi.
Hi, Bob. How are you doing?
I'm very good, thank you. So where do you talk to us from today, Tom?
So at the moment, I'm talking from our environmental and biological testing facility, which is down in Brixham, so the southwest coast of England.
Southwest coast of England, and I'm sitting in the northeast coast of Scotland, so that's a good match up there.
Yeah.
Listen, Tom, tell us a little bit about ARC Marine and specifically what you're doing at the moment.
Yeah, so ARC Marine is an eco-engineering company, and we specialize in nature-inclusive design and environmental monitoring of marine ecosystems. So our main focus at the moment is to improve how offshore energy companies like oil and gas and offshore wind protect subsea assets to benefit themselves and the environment.
Okay, so when you talk about that, is that about providing consultancy support, or is that providing them with any equipment or any products at all?
So it's a two-pronged approach. So we've invented and developed reef cubes, which are a patented building block for the ocean. And we sell them as a precast concrete unit to protect cables and pipelines. But we also offer a consultancy in terms of the marine scientists who then monitor the ecosystem that's developed to create a biodiversity report and to ensure that nothing is going on untoward below the ocean. So it's a sale of precast units and monitoring ecological services.
Okay, so in the few minutes that we've got together, which one of those would you like to talk about, given this is your time? Do you want to talk about reef cubes, or do you want to talk about the broader consultancy services?
Reef cubes is the main one.
Right, assuming that I'm somebody who doesn't know what a reef cube is, tell me, what is it?
So reef cube is a precast concrete unit, but it's not. So they range in sizes from 150 millimeter to 2 meters, and they weigh from 5 kilos up to 10 tons. And they're modular, so they can be combined for added complexity. So you can have a 2 meter cube with 150 millimeters inside of it to add greater complexity and to cater for different species. But it's not concrete how we know it. So the concrete is engineered to be of a low pH. So the adhesion of marine life happens really, really quickly. We also don't use any Portland cement in the mix whatsoever. So we have about a 90% carbon saving to standard concrete. And we only use recycled materials in terms of sand and aggregate. So we've got a really good circular economy process going on with the product. And we estimate, we've got the University of Exeter doing some life cycle assessments, but we currently estimate that they'll last about 500 years once they're subsea.
Okay, is there an opportunity to introduce ash from incinerator into that as well?
So we have trialed. We've trialed with PFA, so pulverized fly ash, but we're going towards a range of cements which use GGBS, which is ground granulated burnt slag. So the waste from steel manufacturing processes.
So predominantly, you're taking what other people would consider to be waste streams and creating these products. Is that a high energy process, or is that something that you can do in an eco-friendly way as well?
So the process of actually bringing the raw materials together and making a reef cube is exactly the same as standard concrete manufacturing. So we use an off-the-shelf concrete mixer, but all the additives go in a slightly different way, slightly different ratio, and we've got quite a faster setting time. So we've got to be a bit clever on how we get stuff into a mold and out of a mold.
Okay, but there's no furnacing or kiln. No. It's a kind of and setting process that you've got.
Exactly.
So, in terms of how far along the journey you are with these, are you currently selling them, or are you trialing them, or where are you on that development cycle?
Yeah, so we are selling them as part of pilot projects. So we classify reef cubes at about a TRL 6-7.
You've used terminology there, a TRL 6 or 7. What does that mean? They're almost ready for sale.
Yeah. So technology readiness level.
Right.
So we are selling reef cubes as part of pilots in Holland, as part of the Rich North Sea project, which is to target sharks, cephalopods, and rays.
When you
And
say
we've
target
also,
them, you're trying to encourage their population
yeah,
of areas, yeah.
yeah, that's right. We're providing a nursery and breeding ground and spawning ground for the adult species to lay their eggs inside reef cubes, and then that will become an established habitat for them to hatch and grow up in.
So are there any areas where you've actually got them in a marine environment and you're already seeing the difference that it's making?
Yeah, so we have about 150 reef cubes off the southwest coast of England around an aquaculture site. And we have 200 reef cubes in a freshwater site, and that was specifically targeting the repopulation of the white-clawed crayfish.
And is it working so far as you can tell?
Yeah, so the studies are still ongoing. So we're having comprehensive biodiversity assessments done on an annual basis. But the interim results are really, really positive. And we pit tagged 36 crayfish, released them onto the reef, and we're going back each year to see where they're sort of burrowing in and where they're staying. And in Torbay, it's a project they've been working on and building on for the past 2 years. The last deployment, or the most recent deployment, happened about on the 1st of April. And a further 100 reef cubes went in, about 16 ton in total weight. And already we've had spider crabs, edible crabs, lobsters, all sorts around the reef.
When you're deploying these, how careful do you need to be? I mean, can you throw them off the back of a boat, or do you have to place them carefully and align them all on the seabed, etc.?
So we normally do an environmental impact assessment to see what's on the seabed before they go down. So we make sure nothing's crushed during that process. And at the moment, we're deploying them using standard methodology, so quick release hooks and block grabs, that type of thing. But we're also speaking to deployment contractors about deployment straight to the seabed. And we're just sort of getting through what characteristics we need reef cubes to be to withstand that type of impact to the seabed.
Okay, so in terms of the future of this, I mean, you talked about a couple of limited deployments already, but in terms of the industrial use of this, who's going to use it and what benefit do they get from it?
So the main customer, if you like, would be or user would be a developer and a subcontractor. So if we were to have an offshore wind farm or an oil rig who needed to protect pipeline or cable, where normally they'd use a rock berm or they'd use concrete mattressing or rock bags, what we would say is let's, instead of placing limited capacity material that will offer minimal environmental benefit, or in some cases plastic ridden material which normally has to be recovered, let's use this opportunity to deploy reef cubes. The subcontractor gets a product straight off the shelf, which is what they're looking for, and the developer then actually has a net benefit to their project, which normally they're fighting to convince people that there is a benefit to the environment in what they're doing. And also they save the decommissioning cost. One of the biggest selling points for reef cubes is because we've created an ecosystem and that we've actually repaired or mitigated any environmental impact, let's not remove all this infrastructure like they're currently doing with concrete mats. Let's leave them down and let the benefit carry on for legacies to come. And in which case the taxpayer and the developer then save the decommissioning costs.
Excellent. So potentially a huge economic as well as environmental benefit if people get to.
Yeah.
So what's the next for you? What's the next part of your business plan? What are you doing after this then, Tom?
So we were hoping 2020 was going to be scale up. So we're trying to complete our pilots, and luckily the team are really persevering on, and we're still deploying as scheduled. I think the main thing we need to do is break into oil and gas as a key market for us, and we're yet to secure a pilot in that space. So I think if we can secure our pilots, complete them on time, safely, with no negative results, then it would be about scaling the business and making it affordable to all offshore construction projects.
Excellent. Well, good luck on that journey, and it's been great talking to you, Tom. Thank you very much indeed for your time.
Brilliant. Thanks a lot, Bob.
So now I'm delighted to welcome, I've got two guests with me now. I've got Trevor and Jonathan from VROC. Now, VROC's a company that's actually based in Western Australia, but has ambitions way beyond that. And they've applied some seriously interesting technology, but I'm not going to tell you more about it. I'm going to ask them. So let me start with you, Trevor, and say, VROC, what is it you do?
Well, thanks, Bob. So VROC, we're an artificial intelligence company, and we specialize in processing industrial data, especially from oil and gas and energy assets. So we use artificial intelligence to try and learn about how these facilities work and provide the operators with insights to help them optimize the production and reduce their downtime.
Okay, so you've used big words there like optimize and intelligence and artificial and all that kind of stuff there. In simple terms, when you say you help them to do things, how? Give me an example of one way you might help them.
Yeah, sure. So obviously these are extremely complicated assets with lots of moving parts. And so it's very difficult for these people or the operators to understand what's going on with this piece of equipment at all points in time. And so what we do is we help them focus on the really important areas, the areas that are going to cause them the most problems.
So give an example of what that might be on a particular platform or rig or something.
Yeah, sure. So on an offshore platform, it might be a gas compressor that might be failing. It might be a power generator that might have some problems. It might be one of their production wells that might be producing too much sand or too much moisture.
Okay.
So there's a whole lot of moving parts on these facilities, and the idea is to use this new technology to identify exactly where the critical points of failure are and where they need to focus next to make sure they maintain their production rates.
And does that give them an early warning of things that are about to happen that they wouldn't know about?
Yeah. So it's monitoring the whole plant in the background in real time, and it gives them an early warning anywhere from days to weeks before certain incidents happen.
Okay, that's very interesting. So tell us a little bit more about where this came from. Where did the idea come from, and how did you develop it?
Yeah, sure. So my background's in industrial automation. So I used to write the software that controls and runs all these facilities because they obviously all run automatically. And so someone has to write the software and the program to run these complicated things automatically, and that's what I used to do. And so what we found 7 or 8 years ago was that these facilities were producing just lots and lots of data that people were storing away and being very protective of, but not doing anything with. And so that's when we kicked off this R&D project to try and work out, what can we do with this data, and what value can we provide our clients, and how can we provide a service to them where they can actually make use of this data that they're not doing anything with at the moment.
Okay, so does your system, is it consist of purely software, or is there hardware involved? And are you really looking at using existing data streams, or do you generate additional data streams?
Yeah, that's a good question. So generally with offshore oil and gas or complicated assets, they've generally got enough sensors on the existing facilities for us to do what we want to do. So they're already generating heaps of data just because they need that to run their facility. So for most assets, the data that they're already collecting is plenty for us to do what we want to do. For some assets, such as some of the older drill rigs, they may be very, rudimentary in the way that they're controlled.
Yep.
And so they may not have enough data, but the great thing now is that there's lots of low-cost wireless sensors that are all battery-powered. You can just stick them wherever you want to put them, and they start streaming through data and allow us to run analytics on the equipment without having to spend a lot of money on new sensors.
Okay, can you give us an example of one that you've done, either in a field trial or a test or something, and what happened and what the outcome was?
Yeah, so we do lots of POC. So yeah, we've got heaps of examples of this happening, but I guess
just give me the best one then. Yeah.
Yeah. So generally, to give you one that's not too technical, I guess. So for example, we're working with an operator in the North Sea that has a brand new FPSO, which is obviously a huge production platform. That's got 200,000 sensors on it, and they've got 3 guys that are trying to work out exactly, what's going to fail next. And so what we did is we obviously took all that data and we ran it through our system, and we focused on a few key areas for them. And we identified, to give you a specific example that we like using, we identified a potential failure on a mechanical seal on one of their pumps. We identified it 10 days before the thing actually was going to fail. And what that allowed them to do was, because they knew ahead of time that this mechanical seal was about to fail, they were able to shut down that pump and switch to a different pump. And maintain the production. They've sort of advised us that if they didn't change that pump, that mechanical seal would have basically been catastrophically destroyed, and so they would have had a much larger repair bill because the seal would have been destroyed. Plus, they would have also suffered the downtime of having that thing fail unexpectedly. So it's turning these events from unplanned, surprise failures to a planned maintenance event.
So you're talking from Australia just now, Trevor. I'm sitting in Aberdeen. What implications does this have for the potential of the UK oil and gas industry? And Jonathan, maybe I'll turn to you on this in terms of where do you see this having an impact on the UK industry, for instance?
I think there's going to be a big impact in the fact that more and more companies are looking at how they can use this type of technology to really get to the root cause of what a lot of the problems they're facing are. As Trevor alluded, there's so much data out there, but no one's really using the majority of it. They're playing with little bits and pieces. They're doing some diagnostic work, but when you actually bring in artificial intelligence and the power of that system, it can really start to link all the different components of a platform together and really start to see what's going on. Effectively, what it does is it gives you a crystal ball into what your asset looks like, and looking ahead, where are the potential problems going to be that you can address now rather than waiting for the failure to happen.
I like it. So Trevor, coming back to you in terms of where are you in terms of the stage of development of the business? Are you at the start of the curve? Are you midway? Have you dominated the world? Where are you?
Well, I think, we're obviously an established business, so we've been around. Some of our clients have been with us for almost 3 years now. So for an artificial intelligence or a predictive maintenance business, we're probably quite mature considering it's quite a new industry. So we do have a lot of experience in what we do. I guess at the moment we're in our scale-up phase, I guess you would call it, where we've got proven technology. It's been production tested. It's been running in service for a long time, and so now it's just a matter of scaling it to more and more clients and to more assets across our existing client base.
So does that mean your big challenge now is effectively marketing and sales to get out there and actually shift more units?
Yeah, exactly. Yeah, just how do we get the message out there to more people?
Excellent. Well, guys, it sounds as though what you're doing is producing a real benefit for the people that kind of use your technology. If it can help them to, as you said, Jonathan, have a crystal ball that allows them to see potential failures before they could possibly see them otherwise, then surely that's going to prevent a whole lot of potential production problems and also potential, safety issues and environmental issues as well. So good luck on that journey, guys, and I wish you every success. Thank you for talking to me. So thank you very much indeed for listening to our podcast. Two deeply interesting companies, I'm sure you'll agree. Now, this is a series of 2 podcasts we've done for this. So if you haven't seen the first one, please check it out and go back and have a look at it. Thank you for your time. Thank you. Goodbye.
Thanks for listening to OGV Podcasts. For more energy podcasts, energy news, TV, events, and much more, visit www.ogvenergy.co.uk.